Good afternoon, and welcome to this afternoon's set of featured presentations. I'm going to introduce the first one, and then it'll be followed by a couple of others. I'm Mike Packer. I'm Director of Advanced Production Programs for Lockheed Martin Skunk Works. I also serve in SME as the Treasurer for SME and as an International Director. I would like now to introduce our first feature speaker, Mr. Eric Schrock, a colleague and good friend. I can't tell you or share with you his formal title, it's classified, but he will give you a little bit of his background as well as that of the Skunk Works. If you hear a nice warm round of applause to welcome Eric to the stage.
Thanks, Mike. Everybody hear me all right? If I step away, this sounds good as well as here. Great. Hey, I just want to thank everyone for the opportunity to speak today and share a little bit of the Skunk Works history with you. As Mike had mentioned and the video kind of introduced, this is the beginning of our 75th year, and that's been a lot of innovation and a great history, and I want to take some time to discuss that today. And I'm going to focus on some of the older things, some of the things in the background. We may be familiar with a lot of the more recent innovations that have come through the Skunk Works, but I want to talk about kind of how everything gets started, because when you look at it, it's really a history that can't be separated from the history of our nation and the world for those past 75 years, and it's a history that kind of set the standard in a lot of ways for new product development. If you look in a lot of business books and things like that, they'll discuss lowercase skunk workses with little s's and little w's, and I kind of want to give people a feel for where that came from. Mike said my title's classified. I don't think that's the case. What I think it is, it's just like with any large organization, the titles just change so quick it's hard to keep up with. And if I had a day job right now, other than speaking here at AeroDef, it would be as the Deputy to the Vice President of all of our intelligence, surveillance, and reconnaissance and UAV programs. So basically, if the Skunk Works makes it and it spies on something, it falls under my world right now. But one of the things that I enjoy about my background is that ever since I was in 5th grade, growing up in the middle of nowhere in western Pennsylvania, I wanted to work for the Skunk Works. All of the airplanes that I liked, all the things that I thought were just incredible about what our country brought to bear as instruments of foreign policy, all came out of Kelly Johnson's shop. So I kind of set my sights on that, and I've been able to do that and very fortunate in that regard. And I want to share some of that passion with you today. If you think about the Skunk Works as being the leading edge of all of the airplane business for Lockheed Martin, the things we've done there for the past 75 years are prototypes, one-off demonstration vehicles, and also the special mission airplanes, things like the ones in the video that you saw that would be the U-2s, the F-117s, and the SR-71s of the world. And then we'll also do the things that make Lockheed a lot of money. We'll do the first prototype for that and get that up in the air, such as the X-35, the YF-22, and we'll look and we go back into the history that we've been doing that for a really long time. So it's all great work. It's all furthering the goals of our nation. And let's go ahead and get started looking back to 75 years ago or so. You can't start a history discussion of the Skunk Works without bringing up Kelly Johnson. Of course, Clarence Johnson came out of the UP up in Michigan, and in 1933 he applied to the Lockheed Corporation for a job, and he said, I really want to do some aerodynamics and design work. And they replied to him, Kelly, that's great, but finish your master's degree first, because we've got a project we want you to work on. And this was that project. This is the Lockheed Model 10 Electra, and for those of you that know Amelia Earhart's round the world trip, she did that, well, as far as she got, in an Electra just like this one, but the tail was different because the tail was what Kelly Johnson worked on at Michigan for his master's degree. Ended up with an H-tail, much like the one in the P-38. It's funny, Kelly had a hand in designing a P-38 once he got to Lockheed. So when he finished that work at Michigan, his professor's name was Dr. Stalker. That's a little bit creepy, but just filed that away for an airplane trivia contest someday. He came in and he was a 35th employee that Lockheed had at the time. And he had many things going on. The P-38 he worked on, the Hudson, other airplanes that were moving through the factory at Burbank at the time. But he had a passion, along with Hal Hibbard, another Lockheed engineer, for the pioneering field of jet propulsion. Now this was 1939. And the Germans had been doing some experiments in this area with the Heinkel 178. You may be familiar with that at Hans von Ohain's centrifugal flow jet engine, and they were flying it around. It wasn't a good airplane. The engine was horrible, but it was a pioneering thing there. Kelly said we could maybe do that one better with an axial flow turbojet and wrap it around a beautiful canard tail-first jet fighter, and far ahead of its time for 1939. So he and Mr. Hibbard went to the War Department. They went to Dayton and talked about what the future of jet propulsion could look like in a real practical fighter. And they replied, we understand, it looks great. There's a lot of things going on right now, Kelly, and the Germans are working on that. We know it, we've seen it. It's just not going to be that promising. So in the meantime, there's so much going on. This is what the factory looked like back at Burbank at the time. Production. It's nice to be in a manufacturing conference, because if I'm at an aerodynamics conference and I bring up the name of like William Knudsen, who came as a 3-star general promoted right out of the automotive industry to run wartime production, and wartime production of aircraft nearly came to 300,000 airplanes in the Second World War. 300,000 just during the course of the war. And Knudsen said, we won the war by burying the enemy under an avalanche of production, the likes of which the world had never seen. That's awesome. Here was what was going on in Burbank at the time. They produced over 9,900 airplanes during the course of the war. Things like these B-17s, Hudsons, and so on. But as the war progressed, started to have some issues. Here's one of those B-17s, just for connectivity. Let's say it was one of those ones going down the line in Burbank, and it's getting torn up by a Messerschmitt 262. The Germans stuck with it. They got to practical jet fighter that was really a great machine that we didn't have a lot of counter for with our propeller-based machines at the time. So here you can see a couple Messerschmitts and B-17 probably somewhere over Europe. Now, Kelly Johnson was going to take this bomber that was built in Burbank that got shot down and avenge it, because the War Department called him back and said, hey, Kelly, you remember that thing you brought us a few years ago? Come up and let's talk about it again. So we were working as a nation on a jet fighter, a prototype kind of thing, and this was the Bell XP-59. It was a research airplane, essentially. Its top speed was slower than the propeller airplanes going on. It was 405 miles an hour. It was not going to be a combat-capable jet fighter. They asked Kelly, come back up, let's talk about what you can do. And in June of 1943, this is the starting gun for the 75 years. So in June of 43, he went up to Dayton, came back with a $642,000 contract and a promise to deliver this first jet fighter in 180 days. This is usually where the history of the Skunk Works starts. I wanted to give you the backstory as to how they got to this point. So this P-80 airplane, which was the first practical jet fighter, is really how the Skunk Works started in June of 1943. Now, there was a problem. At the time, Burbank looked like this. All of these 94,000 people that were working there were building those airplanes, the Hudsons, the B-17s, the P-38s that were going down the line. They said, Kelly, come on and do this work, but we don't have many people. Go and try to find whoever you can and make it happen. So this is just a picture of the shift change at the Burbank plant at that time. And notice above everyone's head, this is a camouflage netting that they employed Paramount, they employed MGM and a lot of the studios to come in and cover the entire Lockheed Burbank plant with a mock city. So in the event of Japanese reconnaissance or bombing raids, in case they got that close, remember the memory of Pearl Harbor was real fresh in everyone's mind, that they might not be able to tell that there's an airplane plant under there. They did the same thing at Boeing in Seattle as well. So Kelly walked around, found 22 engineers. They found a space. The space that they found was behind an existing shop. They used aircraft engine crates to make the side of that, and they covered it with a tent. And this was the space then that they had. You can see this is the only picture that I know of that shows that original Skunk Works tent in the background. It's a P-80 nose section in the foreground for the original, but that back is the tent right there where Kelly set up shop. Now, originally this was just a secret project. There wasn't a lot of discussion, and the name Skunk Works hadn't really been heard of yet. Let's talk about where it gets that funny name. I don't know, maybe some people know that story. There was a cartoon at the time that Al Capp had written called Little Abner. And the Little Abner cartoon was about a bunch of hillbillies, not far from where I grew up in western Pennsylvania, somewhere in metropolitan Pennsylvania there. You can imagine where that is. And they had a still where they ground up old skunks and dead animals and battery acid and things, because in that area you had to have a still. They called that still where they made their Kickapoo joy juice, they called that their Skunk Works. And that Skunk Works was a nice secret place way back in the hollers. Well, one day, one of those 22 engineers by the name of Irv Culver answered the phone. And he picked it up, and because he was in a secret thing he couldn't talk to anybody about, and it was kind of a makeshift ramshackle place with the tent and the crates, he answered it, "Skunk Works, inside man Culver speaking," and after that, the name kind of stuck. Skunk Works with an O became Skunk Works with a U, and we've retained that name ever since, 75 years. It's kind of funny how those things happen. Well, that XP-80 airplane made it to Muroc Dry Lake, which is now Edwards Air Force Base, 143 days later. They actually beat that 180 days by a significant margin and took it up there and got it in the air with their 22 engineer team. They only had 80 people in the shop as well. And here you can see it on the dry lake before one of its flight tests. The airplane was very successful, saw very limited action in the European theater before the war. And now we talk about being risk averse. At this time, they'd never built a jet engine powered airplane before. They had to figure out things like how to build an inlet duct, and in the course of the testing, it actually collapsed. They had to rebuild that engine duct right there on the spot. There wasn't a lot of review boards, there wasn't a lot of discussion. It was just go and get the job done for an urgent national need. And that kind of set the tone for the Skunk Works. That airplane was built using Kelly's operating rules, of which there are 14 that go on to describe a lot of common sense things. Here's the abridged version. And if you look at it, it makes a lot of natural sense. Why wouldn't anyone want to run a program like this? But like many simple rules that look easy at face value, they're really hard to implement, especially in today's culture, and you can see what some of those are. Like keep the number of people to an absolute minimum, 10 to 25% as to what you might see today. Minimize access by outsiders. It's not strange to declare something a secret project just to keep people out for those that you don't need help for. And make sure that you do things like minimize the number of specifications. If you look and see the number of specifications for the U-2 or the Blackbird or the F-117, they were in tens of pages compared to the thousands of pages of things we see today. And today, out of that thousands of pages, a lot of times it just references a checklist of 1,000 other pages over here and 1,000 other pages over there. So these kind of things kept things to a minimum. And that P-80 airplane led to the production of a lot of other P-80 airplanes, which led to the production of a trainer version of the P-80 airplane called the T-33 in use by a lot of air forces, and also an interceptor version called the F-94. Altogether, that one Skunk Works XP-80 prototype led to over 8,200 airplanes for all of the rest of Lockheed and the California Lockheed Corporation, which was a lot of business. So this was the ending of the 40s, the early 50s, and the Skunk Works hadn't been stood up as an official standalone organization at the time, but those people that had learned all those lessons on the P-80 applied them to a lot of other prototypes that Lockheed built in that same Skunk Works tradition. And just to touch on some of them, you might recognize the XC-130. So in 1954, the Air Force had a competition for a airlifter that we responded to with this airplane. The first two of these were built in Burbank, California, and then because the Korean War was starting at this time, they envisioned another huge ramp up of production, and the government asked Lockheed then to take over the Marietta, Georgia facility that Bell had shuttered after the war building bombers, and to produce the C-130 there. So then only the first two of these were produced in Burbank. The rest of the C-130 line moved to Georgia, where it's still in production to this day. The F-104, too, the first Mach 2 capable fighter airplane, an interceptor. We had built over 2,500 of these for a lot of partner nation air forces such as Germany and the Netherlands and Italy. And it was a great airplane. And also over 2,500 airplanes of this type were produced. But there was a reason why we built this airplane. And that was to try to counter some of the Russian threat that we saw at the time. And in the early 50s, we were really trying to get our handle on this. It was hard to tell exactly what was going on. There were the Red Square parades where the Soviets would roll out the big missiles and all of their troops and their latest tanks. They would fly their newest aircraft overhead, and we would sit and watch this from a distance, and our spies on the ground would take notes. And Eisenhower was desperately trying to figure out exactly how much he had to counter. What were their latest weapons? How many did they have? And even little-known weapons such as giant trains made out of corn plying the Russian countryside. Nah, I don't think that was a weapon. I just love that picture because the old Soviet propaganda is just so, in your face. But anyway, they wanted to try to see what was going on. So Kelly Johnson had talked to the Air Force, who was starting a competition at the time. And what the Air Force wanted to do was to look deep inside Russia to try to see what was going on. But the Air Force only wanted to fly along the border and look in as far as they could. So they were going to look in like this and try to see what was happening. Now, they had contracted with Bell, and they had contracted with the Martin Company to build an airplane called the X-16, giant wing, get it up high. Bell was going to take a B-57 bomber and put a huge slab wing on it to try to get it up there as well, and keep an eye on what was happening. They said, Kelly, we really don't want to talk to you about this. He had a great idea to take that F-104 fuselage and put a giant wing on it and see what it could do. He said, look, we've got a lot going on right now. Lockheed's got a lot of work, really, in what was like an industrial-based decision at the time. Don't worry about it. He didn't think that was a good enough idea, and he found some friends in the government that realized the fact that all of us would come to the conclusion that if I'm Russia and I've got all that Russia to go do stuff in, I'm not going to put the good stuff on the border where anybody can look in like this. I'm going to put it at really deep places like Capistan Yar. I'm going to develop my weapons deep inside the country. So the CIA wanted, newly formed CIA, was going to take it up one notch. They wanted to directly overfly the Soviet Union to get to where the good stuff is to try to figure out what was happening. And so Kelly was very successful in discussing that with the CIA and then leading to an airplane that became the U-2. So this U-2 was the U-2 of 1954 that was designed from contract go-ahead to first flight in 8 months by a team of 20 engineers. So 10% less engineers than they had on the P-80, from 22 to 20. And first flight in 8 months, like I said. So the U-2 then started operations really quickly after that with the CIA. It was a project that was so secret that nothing inside the program was marked secret. Just in case it were to fall into enemy hands, nobody would be able to tell if it was sensitive or not. Other things, the pilots and so on being recruited from the civilian ranks to go and fly it. There's a lot of early U-2 stories that would just make for great discussions. Now, the interesting thing about the U-2 is, from the time it started in '54, we knew the Russians were working on advanced air defense systems. We knew that they had fighters that were designed to protect their homeland and that they could see and detect this thing. We figured we'd only get 2 to 3 years out of it before it was detected or even worse. Well, it worked out that we were doing things to try to defeat what was happening. We were starting to use stealth technology in the 50s on an airplane like this, and you can see these 3 pictures of U-2s show wires being strung on it, a quarter wavelength apart to provide if anybody in physics, cancellation signal 90 degrees out of phase. We also put magnetic absorbent material on it. You can see the black patch on the picture in the upper right, to see if we could somehow reduce the U-2's susceptibility to radar. It had the altitude. At really high altitudes, the Russian airplanes couldn't get to it. In fact, they had sent so many of their airplanes up on ballistic trajectories to try to get close to a U-2, they could never get guns or missiles on it. They sent many surface-to-air missiles up too, and they shot down far more of their own airplanes with those surface-to-air missiles than they ever got close to a U-2. But any student of history would tell you, on May 1st, 1960, so 6 years after it was in service, in May 1st, 1960, they did get Francis Gary Powers, and quite a humiliating thing for Eisenhower, who at the time was advocating open skies over Russia so we could see this. Of course he was, because we were already doing it. But whenever they got the U-2 and they got Gary Powers, it was an international incident. And at that time, then Eisenhower said, I got it. We're never going to do manned overflights again. So in that, they went on to do greater things. Starting in '57, here are 3 pages from Kelly Johnson's notebook. Because they knew the U-2 was going to be vulnerable, they started to look at alternatives. What could they do to get it faster? What could they do to get it higher? What could they do to reduce the radar susceptibility of these kinds of airplanes? And so here you'll see 3 notes from Kelly Johnson's August of 1958 on, if you can see the first one on the left, it says, a study of getting Archangel 2 to 100,000 plus feet altitude by going to Mach 3.2. So the U-2 was called the Angel, And if you're going to have something that's going to replace an angel, you better call it an archangel. So that became the name of the studies for the U-2 replacement, if you will. And this became a competition between the Lockheed Corporation and the Skunk Works, and also at Convair, who was working on a derivative of the B-58 Hustler, which they called Fish, which was also a Mach 3 plus machine that was intended to go to real high altitudes and take pictures of nefarious things happening on all over the world. Well, a lot had to do with our relationship with the CIA already and the contract for what became the A-12, the A for Archangel, the A-12 being the 12th of its series in all of the designs that Kelly Johnson and his team would look at, then was awarded to Lockheed in 1958. And this was the CIA airplane that was pressed into service. Now, Mach 3 plus, it was a Mach 3.4 airplane. It had the coolest temperature on this airplane at cruise was hotter than the broiler on your stove. The CIA version had one pilot in it. This, due to its success, became picked up by the Air Force for the SR-71, which first flew in 1964. But this airplane flew in 62. And if you think about when it started, 58, 59, 60, 61, and 62. So in the course of 5 years, they designed an operational Mach 3.2 aircraft where pretty much everything had to be invented from scratch. The titanium manufacturing processes it needed to be constructed. And by the way, you know where the titanium came from for the SR-71. It was all mined out of Russia. And through several front companies came back around to it. But how to do that to make it in a way that it was reduced in its susceptibility to radar and also sustain those speeds and altitudes. There was also another version of it for the YF-12 that was a fighter version for the Air Force. And together, all of those Blackbirds had a great history. Now going back to the team size, the team in order to do the A-12 was only about 120 engineers to cover the waterfront from design all the way through manufacturing. And that got larger with the Air Force airplanes and the fighters to at some point between manufacturing, production, and engineering. At one point in the Skunk Works, there was over 6,000 people working on over the Blackbird and their derivatives. But really an impressive airplane. However, you remember the operative word that Eisenhower said is we're never going to do manned overflights of the Soviet Union again. Didn't say anything about unmanned overflights of denied territory. So in 1964, CIA came back to the Skunk Works and said, you know, what if we have a drone that we launch from the back of the Blackbird at speeds of over Mach 3. It then separates, goes 3,200 miles outside of its way in denied territory. And keep in mind, this was before we had drones and UAVs and that was part of our everyday discussion. Here was something that was going on in 1964, 1966, over 50 years ago, that had these kind of technologies in it at these speeds. So, however, one thing they didn't have was all the computers and data links to send that information back. So its camera pod then, after taking those pictures over bad guy territory, would then come back over good guy territory and get spit out, descend under a parachute, and then be captured in midair by a C-130 with giant scissors on its nose. Then they would roll that camera on a, back into the back end of the C-130, take it down and develop the film, and hopefully see amazing things. So this airplane, which is called Tagboard, that was the name of the drone, or the D-21, started development in 64, had its first captive carry flight in 66, and was started then in 1968. But we did, in an operational use in a program called Senior Bowl. We did have some issues with it though. It was even a little bit too risky for the Skunk Works and Kelly Johnson. We lost a A-12 mothership and a drone when it struck the tail on separation. And this is a video that's out there. You can see it on YouTube. One thing that is, well, let's get back to what they did. They then started to launch them with rocket boosters from underneath B-52s for operational missions. Those operational missions, they can't go into a lot of the details today. However, we do know that one was lost over the Soviet Union, and pieces of it came back in a really interesting way. The Russians saw it, they tried to re-engineer it and see what they could make. They made a D-21 look-alike called Voron that they couldn't actually get anything to happen with, but they did get a piece of that back in after relations thawed a little bit, and a Russian diplomat presented that to our government in the 1980s and said, look, we have a piece of your stealth fighter. They knew what it was, but it wasn't a piece of the stealth fighter. However, talking about the stealth fighter, we'll move on to this. So we knew at the time, and we had a lot of information about how to reduce the radar susceptibility of airplanes. We did it on the U-2s. We had an operational SR-71 and a D-21 that actually proved that out. But one thing that was a challenge is that we couldn't tell anybody about it. There was a competition going on through DARPA in the early 70s that was called Harvey, named after Jimmy Stewart's 6-foot-tall invisible rabbit. And it was about what if, just what if you could reduce the radar cross-section of an airplane to the point where it couldn't be detected? What could happen then? So that program came, and Lockheed got word of it, and it got to the point where they wanted to build a demonstrator aircraft. And we were cut out of it. At the time, we weren't doing much fighter work. We hadn't since the F-104s. And they said, Lockheed, you don't really need to be in that. We said, we'll buy our way into it. We'll pay for it. Just let us compete. Let us compete. And by the way, we have done all this other stuff. Kelly Johnson and Ben Rich went to the CIA and got permission to discuss some of the things that they had put into place on the Blackbirds, on the D-21, and on the U-2. And when that got to the government, they said, oh yeah, you probably should play in this. And the key to this whole thing was, for the first time in the late 70s, we developed a computer program that could predict the radar cross-section off a flat plate and its scattering. We kind of knew what to do before. In the Blackbirds, we would test things in an anechoic chamber, and we would try different things and look at the radar return. Then we would go tweak it and then look at the radar return. But we didn't have a really good scientific way of estimating what would happen after a design change. It was cut and try and cut and try. But this computer program called Echo 1 was really the first time that we could design in the radar cross-section that we wanted. But because it was constrained to flat plates, it made that demonstrator airplane called Half Blue a really interesting looking airplane made up completely of flat plates. We could actually predict that radar cross-section, make it eye-wateringly low, so low that when it was determined how low it could be, they actually classified it higher than anything at the Manhattan Project at that time, because it would represent such a huge offensive capability for our air forces. So with the success of Half Blue, the 117 came, and this F-117, being the world's first practical stealth fighter, started in 1978, and the initial operational capability was done in the early 80s, and only like 2 years after first flight. And the airplane flew about 2 years after the contract award. Now, what looks like a kind of a clunky aerodynamic shape is actually very sophisticated. And I always like to look at this from an engineering perspective as a great compromise. How years of airplane designers that wanted to make everything sleek and gorgeous had to kind of bow to the needs of the radar cross-section engineers and make something that worked for both communities, and came up with the 117. Really neat system. And just to, we've heard of the things it did in the first Gulf War. It represented less than 2% of the entire force, but it had all of the targets over downtown Baghdad and over 80% of all of the real high-value targets during that conflict. We wanted to take then those lessons learned in stealth and move it on to the prototype for the F-22. This YF-22 is the first of its kind to produce a fighter airplane that was a true pilot's airplane that could maneuver like it needed to get a fighter pilot what they wanted, but also to have low radar cross-section and cruise supersonically without afterburners. And then similarly applying that kind of technology to the prototype for the F-35, the X-35, which was kind of bring that together in a low-cost system that could find the needs of both the Air Force and the Navy, as well as the United States Marine Corps for a vertical takeoff version. And those are the kind of things we think about now when you go into the Skunk Works history, and you can see the things that are actually impacting aerospace today, the F-35 and the F-22. If back at our history, to look at the things that we've done over the years, one of them is the top, where we develop and field special mission airplanes like the U-2 and the F-117. But there's been so much more than that, too, in terms of the prototypes that we build, like the X-35, the F-22, and going back to the C-130 and F-104 as well. Those things make a lot of money for Lockheed, and they all come out of the Skunk Works. Now, new things have happened, and the Skunk Works, like any other institution, is evolving. And because the technology work is so important to everything that we do, the Skunk Works developed technology for radar crossing. They just developed technology for all of the stealth stuff and the titanium for the Blackbirds. But all of those technological innovations were just for the Skunk Works. Now, the Skunk Works serves the larger Lockheed aeronautics community for technology development in advanced structures, in propulsion, and low radar cross-section, open mission systems and sensors and things like that. We do all of that technology development in the Skunk Works now, so we can transition that into the improvements of our existing products. So when something needs to be done for the C-130 or the F-16, we kind of handle those improvements too. So that's an evolution to the things that we have done in the past, and kind of helps us help out the rest of the Lockheed Corporation in a better way. So in that 75-year history, just take a look and see how much time we've got. There's been a lot going on, and I could have gone on a lot longer to talk about things that weren't in there, like the JASSM surface-to-air missile, or the Glomar Explorer ship that we had helped build to pull a Russian submarine off the ocean floor. But I think these innovations that we've talked about have been instruments of foreign policy that have helped keep our nation and the rest of the free world safe. And technology and innovation are kind of a new buzzword now, and a lot of people, when they think of technology and innovation, it immediately goes to, well, my phone, and I got this new app. But I tell you, I think everybody in this hall would agree that when it comes to it, technology and innovation is about doing things that move people together and not further apart. Not like Snapchat, not like Facebook. And we're going to talk about these things here that really make a difference. You can't compare a Blackbird or a 787 to that in my book. So I'd just like to take that time to thank everybody for their attention, for taking some time to learn a little more about the things we've done in the Skunk Works for the past 75 years, and hope you enjoy the rest of the conference and the things to follow. Thanks.
Thanks, Mike. We got a couple of minutes for a couple of questions, if we can do that.
Yeah, we can do that. Absolutely.
Okay, we've still got a few minutes here for a couple of questions. Also, Eric will be around this afternoon, but we can take a couple of questions from the audience. We're not using the online system for questions. Do we have some questions?
What are we doing now? Okay. So, that's a really neat thing about the history of the Skunk Works. When you look back, we can talk about all this neat stuff. And if we want to look at the future, I can say that we are doing things in those 4 areas. We are working on new competitions, new prototypes. There are things out there like a naval-based aircraft called the MQ-25. That is a tanker that's also a UAV. We're working on, like the rest of the aerospace industry, new concepts for mobility aircraft, new concepts for fighter aircraft. There are also things that we're doing to revolutionize the world of mobility using hybrid airships. Hybrid meaning not like a Prius where it's half electric and half conventional. Hybrid where it's an airship that actually gets some of its lift from its aerodynamic shape. And in doing that, you can reduce the cost it takes to move goods from point A to point B. There's something else we want to do that is looking to reduce or to change the way we fly supersonically. Right now, it's against the law to fly supersonically over land in the United States. We're working together with NASA to build, to try to figure out a way to come up with a demonstration airplane that could fly supersonically, just to test that out. And that's another ongoing competition that we're working on with NASA. Yes, sir, go ahead.
Thank you for letting us know. But do you have projects? I know your projects are very complex, but I'm going to use the word. Do you have projects about civilian drones or military drones that you can talk about?
So there's a lot of, if you saw the introductory video that Mike played before we got started, there were some small UAVs there that we do work with that are quite impressive in terms of what you can do. And we have been working on that in that space for a while for both ourselves and some customers. It's really interesting when you have a small group of people in the Kelly Johnson way of building small teams for an urgent need where you can be a little bit more leaning into challenges that are risk-wise. When you do them in UAVs, it helps with that. And when you do it with small UAVs, you can do even more. So the amount of things we can do with those is pretty impressive.
Eric, we had one question regarding what was Lockheed Martin's contributions to the Glomar Explorer.
To Glomar Explorer. Okay, so I didn't see where that question came from. If you wanted to raise a hand. So Glomar Explorer was at its, the cover story was to try to recover manganese nodules off of the ocean floor because everyone wanted to make money in manganese at the time. So there was a large ship that was structured to take these manganese nodules off the ocean floor, also done with Howard Hughes' shipbuilding work. This was done in the Bay Area of California, and there needed to be a giant claw to pick up this giant manganese nodule off the ocean floor, which just happened to look like a Russian nuclear submarine. The Skunk Works was very involved in the engineering and the development of that claw that was to be suspended under the superstructure of the ship and to go down at the depth. I think that sub was at 10,000 feet or more, and then to reach around that sub, grab it, and pull it off the ocean floor.